Our final example is an equation that ties all our different concepts together from this chapter. So we're going to see a lot of substituting, a lot of rules that we haven't used for a little while, but we're going to use to solve this equation. The tangent of x over 2 minus the sine of x is equal to 0. And for this one, I'm specifically going to say we're going to go from 0 to 2 pi. No, it's not explicitly listed there. Let's just go 0 to 2 pi. So I need to begin by looking at this and say, is there anything I can simplify? Well, sine of x is pretty simplified. But that tangent of x over 2, that's one of those half angles that we talked about. Same thing as tangent of 1/2 of x. And you've got some equations for that. You pull back out your stuff earlier from section 5. You can find all your equations that are the half angle identities. And the half angle identity for tangent is 1 minus the cosine of x over the sine of x. So we'll start by using our half angle identity and simplifying by substituting in. Okay, so that helps us with that. Now where do we go? Well, I can see this equation is equal to 0, and I have two fractions on the left-hand side. So let's make a common denominator. 1 minus the cosine of x over the sine of x minus sine squared over sine of x. And then we can combine into a single fraction. Well, now that I'm to that part, what else can I simplify? Can't simplify 1 and cosine of x into anything. Can't cancel an x because it's everything over sine of x. But this sine squared of x, it'd be nice if I could rewrite this in terms of cosines so everything in the numerator is cosines. And I can. Sine squared of x we know is the same thing as 1 minus cosine squared of x, one of our identities from a long time ago. So 1 minus the cosine of x minus 1 minus cosine squared of x over the sine of x. We can then distribute this negative into the parentheses. 1 minus the cosine of x minus 1 plus cosine squared of x over the sine of x is equal to 0. And when I look at this, I can see some simplification that can occur. My 1's are going to cancel out. So here I'm left with minus cosine of x plus cosine squared of x. So I'm just going to rewrite this in terms of descending powers. Cosine squared of x minus cosine of x over the sine of x is equal to 0. Well, now that we've got these cosines and sines, it would be nice if I could get rid of that sine somehow. So let's do that. Let's multiply both sides by sine of x. So I'm left with cosine squared of x minus cosine of x is equal to 0 times sine of x, which is 0. Now that I've done that, I've got a simple equation that I can work with. Cosine squared of x minus the cosine of x is equal to 0. Let's factor out cosine of x. Cosine of x times the cosine of x minus 1 is equal to 0. Two equations being multiplied that equal 0, which means we can set each one equal to 0. Cosine of x is equal to 0, and cosine of x minus 1 is equal to 0. Here we can take the cosine inverse to both sides. So x is equal to the cosine inverse of 0. And we know the cosine inverse of 0 is pi over 2 and 3 pi over 2. Those two values are on the unit circle. Second equation we got here, cosine of x is equal to 1. Take the cosine inverse to both sides. and the cosine inverse of 1 is equal to 0. So my three solutions to this equation are pi over 2, 3 pi over 2, and 0.